Okay, good morning, class. Morning, everyone. How's it going? Good? Week 5? So far, so good? You have midterms this week? How's that going? Not good? Which midterms? Fluids next week? Oh, okay. What else? 135 chemistry materials. That's a tech elective. That doesn't count. What else? What else? What are the midterms? 171. What is that? Oh, NV environmental intro. Okay. Oh, who's a transfer student? You guys have mass balance? No mass balance midterm? Next quarter? 110A? Process. That was last week? How many midterms for that class? One midterm? How was that midterm? Good? Oh, nice. Process was an intro class, and for me, that was the hardest class in my entire degree. The very intro class. I think they tried to make it a weeder class, and I guess they changed it. Hopefully, they changed it. And then also process control is really hard, but that's your senior year. So, and that's why this class is important, because for process control, you're going to be doing lots of this stuff. So this week it's week 5. Last week I went hard on y'all. This week, we decided we're going to go a little easy because y'all have midterms, right? So yeah, we're just gonna get started on this week. So we're continuing our discussion from last week, which is solving systems of linear equations, right? Which is chapter 4. So last week I gave you guys this warm up, and I said use whatever method you know to solve this equation, the system of equations. And then unfortunately I messed up the coefficients. So this is the same warm up as last week, and this time hopefully now you know how to use MATLAB. So how would you solve this system? What's the first step? All right, so you write the matrix of coefficients, and then you write a vector, call it B, which is the right-hand side of the equations, right? And then you can define the augmented matrix, you combine them together. And then what kind of methods have you learned so far to solve this system? Okay, Gauss elimination, what else? Gauss-Jordan with pivoting, Gauss elimination with pivoting. So raise your hand if you learned pivoting. No? I thought you guys did that, right? You did that? You read the chapter? Raise your hand if you read the chapter. Raise your hand if you're gonna read the chapter 4. Why aren't you raising your hands? Everyone should raise their hands. Okay, read chapter 4. You need to know pivoting. How's the quiz? It's not open? All right, well, my recommendation is you study chapter 4. And so in class, right, in lab, we learn how to like apply the problems, but a quick, quiz tip is you kind of have to just memorize the equations because it's more about theory. So the lab is about application, and then the quiz is about theory. All right, so understand the equations, where they come from. And then my best advice is just memorize. It's kind of like a game, right? So you want to rack up the points for this kind of game, right? So let's go ahead and let's kind of review how to solve this system. Let's just open up MATLAB Grader. So the nice thing about MATLAB, right, is we can have our code from previous codes, and then we can adjust them, right? So let's see. I'm going to try this one, right? So hopefully this code is decent enough to sort of copy and paste. And then this is kind of the same as last week. So we have to define the matrices and try to solve the system. And then, yeah, I think I actually won't do this because it might be finicky with the typos, right? But what I was just gonna remind you all is just that we can automate the process for any sort of code. So like I said, we're gonna go easy today. So we're gonna review everything we did last week because it's very important. And then we're gonna build off of that, okay? So just remember, the first thing I would do is define the matrix, find the matrix A, define the matrix A, and then define the vector B, right? That's the first thing you gotta do. And so I tried to give y'all points for that, but for some reason, for some of you guys, it wasn't working. And so if you received 4 out of 5, you should have received 5 out of 5. So if you received 4 out of 5 last week, then let me know. And then we can work something out. And then the augmented matrix. And then we initialize the method, the algorithm. Okay. So today we're going to learn some new algorithms. We're going to go over one algorithm, but again, I want you to read chapter 4 on your own time. And then yeah, don't worry about this yet. We'll go over this again because as we'll see, all the algorithms are really similar to each other in this chapter, right? So we're solving systems of linear equations, whereas last week we're solving nonlinear equations. Okay, so I don't know, maybe she'll ask you the difference between. So notice how in chapter 3 we're solving nonlinear equations. So give me an example of a nonlinear equation. Okay, x squared, all right. And then this side. What's another nonlinear equation? Yeah, x cubed, yeah, also trig, any trig function. But this week we're solving systems. So what is a system? Yeah, like n equations and unknowns, okay? And then what's the condition for solving systems of equations? The degrees of freedom has to be equal to, this side, the degrees of freedom has to be equal to. So what's the degrees of freedom? Number of equations minus number of variables. Good. Okay, so study the theory because that's for your quiz. And then for the rest of it, that's for the application, right? Okay, so last week we covered Gauss elimination, so we can check that off. And then hopefully you guys can do pivoting. So pivoting just means that if you're dividing by 0, you can't divide by 0, you just switch it. Okay, that's just what pivoting is. Let me know if you're stuck on that. Remember, I have office hours. Also Gauss-Jordan elimination. So it's very similar. You're just switching the equations a little bit. And then so today we're going to cover LU decomposition. Okay. If we don't have time, please go over inverses and then the iterative methods. Also, I can cover it in office hours. And then if you want to review, let me know if we should do like a collective office hours. For inverses, so who are the chemies? So I apologize to the envies. I don't know if you need inverse, but for the chemies, I know for sure you're going to need inverses in your process dynamics class next year. Because that class is very heavy with the math. So I recommend you look into the math, the theory. So what is the process of calculating the inverse of a matrix? So remember, is there such thing as matrix division? No, but you can take the inverse of a matrix, right? Okay, so keep that in mind. Please read those. You're probably gonna get tested on them. But the main 4 are gonna be these 4, okay? So if you're gonna get tested on anything, it's going to be these 4. And I decided to skip the other 2 because honestly, Gauss elimination is Gauss elimination. So they're all similar to each other. You just have to slightly adjust the methods. And so today we're covering LU decomp. All right. So there's also other stuff. Okay. There's also Krauts. So again, slightly different. And then, yeah, and also some pivoting stuff. Okay. So what is LU decomposition? Honestly, it's really similar to Gauss elimination, right? So previously, we used Gauss elimination to get rid of to transform the matrix of coefficients into, so what kind of matrix is this? upper triangular. Why is it upper triangular? Yeah. So do you see the triangle? I want to really, really make sure. This isn't working. Oh, I think if I do it and then quit. Okay. Keep. Yes. All right. So do you see that upper triangular matrix? Right. Again, this is for the theory. This is for your quiz. So really make sure you know the difference if something is upper triangular or the opposite. We're gonna do lower triangular. Okay. And then some of y'all didn't get credit for last week because you didn't finish. You didn't finish the lab. So a lot of you guys, you got to this part, but you didn't finish the actual solving of the system. So who can tell me what those equations give you? So what is xn? It's the solution to the nth value, right? So that's the last element. And then once you know that, what is this equation? What is this procedure called? Yes, back substitution, okay? So we're back substituting. So once we know this, plug it into here, solve that, plug it into here, solve that. And then finally, you back substitute, okay? So Gauss elimination gives you upper triangular matrix. There's also such thing as lower triangular. There's also the identity matrix, right? So make sure you review those math concepts for your quiz. All right, any questions? Okay. So yeah, honestly, I'm really, really pleased by the lab so far. Most of y'all got full credit and there were some glitches, so I do apologize. So, I made an announcement. I really want to make sure that you guys read the announcements. And so if you didn't get full credit, but you think you deserve full credit, please let me know. All right. Okay. So LU decomposition is really, really similar. So all we have to do, we're going to solve the same system as before. So we have our system of equations. So how many equations and how many unknowns? Yes, 4 equations, 4 unknowns. So that means n is equal to n equals 4. Degrees of freedom equals 0. N equals 4. Okay, so we're looking for a vector of size 4. So all we have to do, it's called LU decomposition. I'm sure you can guess why. Because these matrix, we're going to call this what do you think L stands for? Yeah, the lower triangular. And then this one is, yes. Okay, so let's kind of analyze this. The main thing is this matrix, okay? So this is a lower triangular matrix. Okay. So what do you notice about the diagonals? Yeah, so all the diagonal elements are 1. Okay. So let's keep that in mind. And so what do we notice about this U matrix? So what is that? Yes, it's the upper triangular matrix. So L stands for lower, U stands for upper. And then what do you notice about the off terms? These ones. They're all 0, right? So all those terms are going to be 0. So it's called decomposition because we have this matrix of coefficients that we just defined, and then we decompose it. We kind of like almost like factor it out. All right. And then so what's the operation that you're doing on these two matrices? What operation is this? Addition? No, not addition. Matrix multiplication. So do we remember how to do matrix multiplication? We take, this element and this element, multiply those, and this element, and that's just going to be 0, continuing on, right? So if you multiply these two matrices together, you'll get this matrix. Therefore, we have a check to, at the end, whatever you get your solution for this, and you get your solution for L, you get your solution for U, you multiply them together. If it's the same as A, then that means you're right. We have like a check, okay? All right, so before we learn how to decompose A into L and U, do we have questions about this matrix? About this method so far? All right, so let's go ahead and just, let's just go ahead and just do that. Let's just do an example. So we're gonna solve this system. So we have our code from before. Okay, so here's our augmented matrix. So 4, -2, -3, 6, 12, -6, 7, 6.5, -6, -6.5, 1, 7.5, 6.2, 5.5, 16. Okay, so the first step is the same as before. LU decomposition. So we're just gonna augment the matrix. Okay, and so then we want to decompose L and U. So what do we notice about the upper triangular matrix? So do we know how to get the upper triangular matrix? So who can tell me? Yeah, we can use our previous Gauss elimination methods, either Gauss or Gauss-Jordan. Okay, so how did we do that? How did we do that? Okay, I'm gonna go on the whiteboard. So last time I went here, this time I'm gonna go here. So let's do that. I really want to make sure we know how to do this in our brain, not just copying my code, right? Stop for a second. Stop. And yeah, that's nice and big. Can I do both? Not quite. So we're gonna do that. And then we're gonna have the code like that. Okay. Yes. So hopefully that should work, right? I'm trying to show the Zoom so you guys can have the videos. So when you watch this back, you'll be able to see. Yeah, you'll be able to see everything. All right. Sweet. Remember, I post the videos on YouTube, so they're all linked on Canvas. So do go ahead and review those. It's not a bad idea to watch this one and the Friday one, but it's more important that you go back and then do the problems yourselves. Okay, so let's do this matrix. All right, so we have 4 minus 2 minus 3. 6 and 12. 6 minus 6, 7. Minus 1.5. Okay. Okay, so this is our A, and then this is our X, and then this is our B, right? So what's the operation that we're doing on A and X? Yeah, matrix multiplication. It's not addition, right? This is our A, this is our X, and this is our B. So our goal is to decompose A. Decompose A. Goal, decompose A into A equals lower times upper. Okay, so we kind of know how to get upper. So how did we do that last time? So we let the equation 1 equals 2. So let's write it like this. 4x1. And then let me know if I have any typos. That'd be good. Right? So the first equation, I'm just multiplying the first row by the first by this column, right? Okay. And then we let E2. We do it again for the second column. 7 x2 x3 4. Okay, so far so good. Okay, any questions so far? Just like last time, right? So what we want to do, so are we keeping row 1 the same? Yeah, so we don't change row 1. So we're going to change row 2. So we want to change row 2. We want to change row 2, which is equation 2. So how do we do that? We define E2 prime equals, we're going to keep our x's. Okay, so how do we do that? Last time. So E2 prime is going to be, this is the new equation. New equation is going to be equal to the old equation minus some other stuff. So for changing E2 to E2 prime, the old equation is E2. And then we're subtracting. So this is the tricky part for us. We kind of like not really sure what's going on here. So what did we do last time? So we have a -6 right here. We're trying to turn this -6 into what number? 0. So we have to cancel out this -6 using the -6 and the 4. So the way we do that, right, in this case, we're just going to take the -6, do it like this. -6 over 4, right? Times E1 times the 4, right? Times E1 times E1. Okay. So for the first element, you know what? Let's do that together. Let's go on MATLAB. Let's do that together. Okay, so here's our equation. Here's our equation. And we're going to transform this entire equation. Okay. So we're going to change E2 into some new stuff. So therefore, E2 prime should be x1 plus x2 plus x3 plus x4. So we already know what goes here, right? What goes here? Yeah. So this is 0. So this cancels out. So let's go into MATLAB to make sure. Okay. So let's start with let's do one element at a time. We know we can do the whole equation, but let's do one element at a time. So we have this minus 6. So we're just going to call this E2 of 1. Right? And then we're going to apply this equation. So what is that? What's going to go here for doing one at a time? So this is going to be actually A of 2 comma 1, right? 2 comma 1. Let's make sure. That should be a minus 6. Right? So A of 2 comma 1, we're trying to index. We're trying to get that minus 6. Right? Then what do we subtract? We're just going to do it manually. So we're going to subtract minus 6 divided by 4. And then we're going to multiply that by, yeah, A of 1 comma 1. Oh, you know what? Not even manually. Let's just put all the numbers. Let's just put all the numbers, E2 of 1, just to make sure we really, really understand. Minus 6 minus negative 6 over 4 times 4. There we go. So that should be 0, right? Minus 6. Okay, so that's 0. So we turn this one element into 0. And so I understand for some of you all this is review. So if this is a review, that's great. And then we're about to take it one step further. So we really, really need to make sure we understand the mathematics this time. Okay, so that's that first element. Okay. So how do we change the second element? So that's that one. So that goes away. So now you need this coefficient right here. We need to change that one. So we're going to call this E2 of 2. So pretty much it's mostly the same, right? So this time instead of a 6, we're going to get the 7, right? So why the 7? Because we're trying to get this one, right? We're trying to turn this one into a 0. Okay. No. Yes, we're trying to change that one. We're not trying to turn it into 0. We're just trying to change the rest of them. So let's change that one. So that's going to be 7. And look, this is the key. This is what stays the same. And then we multiply that by minus 2, right? I believe that's correct. Yeah, you agree? Whoa. So pretty much notice how this is constant. Yeah. -2. I'm grabbing this one. Yeah. Yeah. So by the way, can you guys see that? Yeah. I'm trying to make sure everything's even here. Okay, good question, good question. Now E2 of 3 is going to be, now we look at what? Yeah, 6.5, right? See how we're like shifting? Started here and we're shifting to the right. That's what the for loops are doing for you. That's what we're doing automatically. So who's gonna, so help me out with that, 6.5 times 3 -3. So now I'm grabbing this one, right? So what we're looking at this this row and this column. So we're looking at the second row. Now we're in the third column, right? Rows, comma, columns. And so what was that? 3 -3. Thanks. And do you see how as we're doing these calculations, we're making a vector, right? That's a vector now. A couple more. Let's do a couple more. Equals. So now which one do I grab? I grab second column, 1, 2, 3, 4. Now let's automate this a little bit. So I'm grabbing the -6, right? I'm in this, grabbing that one. So that's going to be the second row, fourth column. You count, you go down for the rows and you go right for the columns. So that's going to be og 2, 4, right? Okay, and then I'm going to get the first row, first row, 1, 2, 3, fourth column. Hopefully all this is right. Okay, and then finally, we're going to have the B vector. So that's going to be 2. So now the 2 stays constant because we're always getting the second row first. And then we're adding 1 to here. This stays constant times og of 1, 5. So I'm trying to like, condition y'all to see the pattern. So this is going to add 1 on this side, and this is going to add 1 on that side. But what do we notice about the -6/4? Yeah, so we can define a constant. So let's see. Let's plug in our values here. Why did that change? E4 of E2 of 5. Okay. So now we can update our mathematics. We use MATLAB to update our mathematics. So this is 0. We got 4, 2, 3, and that's equal to 11.5. Okay, if you can't see it, it's going to be up here, so you can see it during the lab. Okay, so we can't solve the system, but we adjusted the first term, the first equation, right? So then we generalized this, right? So we took the old minus the -6/4. So now let's let M21. What do you think M21 is going to be? Yeah. Let M21 equal -6/4. Okay. So do we see how we got that? Right. So M stands for multiplier. M stands for multiplier. So the multiplier is basically going to be a constant, a number for each iteration of that row. Okay. So if we repeat this process again, we're going to have some new equations. Okay, so we can adjust our equation that it's basically going to be the new equation is equal to the old equation minus the multiplier times the pivot equation. Let's call that P. So now here's our master Gauss equation. So basically we have new equals old minus the pivot times the multiplier. Any questions about that? Okay, so now I'm going to start automating. So we're going to do the book does it like slightly different, but it's essentially the same. So I'm going to iterate through only A this time. And so we need nested for loops. So why do we need nested for loops? Yeah, so we need to not only go, vertically down. So going vertically is like your J, and then going horizontally is like your I, right? So all I'm gonna do is define. And so do you see how when I tell you guys, you can do math or automation, this is like math. This is just numbers. And then this is like MATLAB math, so it's like level 2. And then level 3 is going to be the automation with the for loops. All right. So we're going to do first let's define the size. Let's call it SA. And then this time it's going to be just the size of, let's do size of aug, size of the augmented matrix. So, in other languages, we don't really need this. And in fact, I think the book does this, right? So that's going to be easier. Rows, columns. See if that, yeah. So we have 4 rows and 5 columns, right? Augmented matrix. And then I'm just going to suppress these. So, like I said, I try to be nice. So if it works, it works. If you like the math, then do the math. I think when I was in undergrad, I did it this way. I did it like halfway math, halfway automation. I wasn't really comfortable with the for loops. So that's okay. Except for sometimes you kind of need the for loops when the matrices are really big. So yeah, so we have 4 rows and 5 columns, right? So we're going to iterate through I. So I is going to be, basically we're starting with, I think of I as the rows. Yes, think of I as the rows and think of J as the columns. Other way around. Think of I, let's see. So we're starting at I equals 1. And then I stays as 1 because we're still in the first column. Yes. So think of I as the columns and J as the rows. Okay. So I is going to be from 1 to the number of rows, the size. Yes. It's going to be rows or columns. 1, 2, 3, 4. Yes. So in this case, it's going to be 4. So let's just make sure. Let's just output I. So all this should. So what should this output? Yeah, it's just gonna. It's a counter. So for loops are just counters. So right. So look, let's do this. No, this is. Let's enter a for loop. This is MATLAB, so it's not Python. Display. Let's enter the for loop. And then, yay, we are out of the for loop. So all I'm doing so far, I haven't done anything. All I'm just doing is demonstrating the for loop. So we read the code, just like the computer. We read step 1. On the very first day of lecture, Fatima asked, you know, what are these numbers? The numbers are like, we're just reading the steps. We're reading like a list of like how to make a cherry pie, right? And so we're entering the for loop right here. So that's line 20. And then we're gonna count 1, I equals 1, 1, 2, 3, 4, 5. Okay. Yay, we're out of the for loop. Okay. So that's I, and we need a nested for loop. So that's going to be from I plus 1. Why is it I plus 1? Because, you know, we're starting here, and that's going to be 1 plus 1, which is 2. All right. So that goes all the way up to the number of columns as well, or the number of rows. So we're going down. Should be up to the number of columns as well, I believe. I, J, and. Right? We agree? So let's enter the for loop. I is 1, 2, 3. So we got a question. Reason I plus 1. Let's cover that real quick. So why do we do I plus 1? Because the first time we do it, we're going, let's look at the matrix. So our I is 1, so we're in the first column. And then our J is, what's our J? Our J is going to be 2 initially, right? So if our J is 2, then we need to increment 1 to whatever row we're looking at. I know it's confusing. I know, you know, all I, J, K, everything. You just have to practice. Just have to practice. Okay, so what did we do last time? Let's write our equation. So our equation is going to be the new equation is going to be the old equation minus the multiplier times the pivot equation, right? Okay, so last time we used OG, but this time let's just stick with only A, so we can change. It's LU decomposition, right? We want to decompose A, so we're gonna do. Yeah, and if you're still confused about the nested for loops, like, trust me, we're gonna be doing. Basically, this is as hard as the coding gets. By the way, there's nothing harder than this code. Like nested for loops is as hard as it gets. Should it be hard? Let's see. So we have I equals 1, and then row is gonna start at 2, and then we're gonna go 1, 2, 3, 4.
I goes down and J goes.
So J is going to be 1, 2, 3, 4. Yeah, that's right. So it's going to go to the right. So you need to get the rows. Actually, you're right. Right? I plus 1. Let me just double check. Let me just double check before I do that. Plus 1. No, it's yeah, it's rows. It's rows. Yeah, because yeah, you can think of it as like corresponding to I columns and J rows. So it's going to the right. Size of 1 is also rows. So this should also be rows then. Let's make sure. Let's make sure.
I think it's because you don't want to mess up with your keys.
Right.
So if you could see, you're gonna reach the point at which you're gonna kind of manipulate your keys. You
Right.
don't want to do it. You just want to focus on your matrix A. That's why you are picking, you know, number of rows.
Right. So we're saying I equals 1, and then we're going to iterate J equals 1, 2, 3. And then we're going to let I equals 2, and then iterate J equals 1, 2, 3, 4. Oh, 2. 2, 3, 4. So it's the number of rows. Yeah, number of rows.
If you pick columns,
Yes, yes. You're gonna exceed. It's gonna go. Oh, J is number of rows, and then it's gonna get confused. Yeah. So let's change that. This is gonna be from 1 to the number of rows, down to I plus 1 also to the number of rows. Yeah. Sorry about that. So I think in this case, it won't get confused because it's a square matrix. But, you know, if you have mismatch, it's going to get confused. Right? Thank you for that. Yeah, any more questions about that before we write the equations? Yeah. So now, last thing we have to do is define our multiplier. So this is going to be, let me make sure. Let's just call it L, because the L is going to be multipliers, right? So that's just a single number. So if it's a single number, stop that. We're just going to do I comma j. Oh no, excuse me, j comma I. So why j comma I? Because when what was our first multiplier? It's 2, 1, right? The 2 is the second row, first column, minus 6/4, right? So that should be, L of ij should be, let's do it for the first one, just to show you. This should just be minus 6/4. Minus 6/4. Okay. So before we do that, I need to, yes. J comma I. So I actually want to define a, a new matrix, call it U, that's just going to be A. Okay. So now I'm going to replace that with U of j comma I divided by U of I comma I. Okay. So it's sort of hard to explain how to derive these. You just have to kind of contemplate, you know, what's the math. So if j equals 2 and I equals 1, then it's going to be minus 6/4. Okay, so we can run that, hopefully. Let's see if that works. Right? So we're starting to get our lower matrix. Right? So it's calculating, entering the for loop, we're getting our lower matrix. And then, so we have all the multipliers. Okay? So what I want you to do is figure out, so now we have all the multipliers on the bottom left. I want you to just update the matrix to have the ones on the diagonal. All right? And then the zeros on the top right. So you can do that in here, or you can just continue afterwards. And then we want the upper triangular matrix. So how did we do that last time? So we're going to let U of j comma colon. So that's our upper triangular matrix. It's going to be U of j comma I. Remember, that's this equation. So then U is equal to the old minus the multiplier. Oh, look. So do we have the multiplier? We do. So we should just be able to do that, right? Times the old. No, times the pivot equation. And the pivot equation is U of I comma colon. So this is just like last time. It's just like last time. The only difference is right here, the L. Okay. So the U should be pretty much good. The L is not really quite complete. What happened to my M? So this is going to be L. L of j comma I. Should be like that. What is the chat saying? How does everyone select the small corner? Oh, okay. Hopefully that's good. Oops, where'd it go? Now finally, yay, we are out of the for loop. Let's output L, let's output U, let's output A. Okay, so our L is almost done. Our U, we have a bug somewhere. This should be J comma colon. Sorry. I'll give you a second. Okay, everyone stop coding real quick. I don't want you guys to just copy the code. You can copy the code during the lab. We have 2 steps. We have 2 very, very simple steps. First step, calculate the multipliers. This is the L. Multipliers, right? Second step, calculate the what? The upper, you change the coefficients. I'll let you copy the code in a second. But if we just blindly copy code, we're gonna get confused. We're not gonna know what's happening. So we're almost done. We have the L and the U. I think there's still one more bug. I'll check out that bug. Right there. So no, should be L, J, comma I. I'll check this bug in a second, and then this one should be almost good. Either way, it's going to be your homework to finish this, and then I'll check that for you guys. So let's just review real quick. We have L. We're not quite done. Your homework is to change those zeros into ones right here. So that's your homework. And then this one, we already did it last time. So basically, you can use your code from last time from right here. Okay. And then are we done? No. We have one more step, which is to back calculate. Yeah. Yeah. So go ahead. What are you going to say? You guys had a suggestion? Yeah. Let me check this code. U of J comma colon U of this one, right? J comma colon. No, this is J minus L of J comma I, U of J. Yeah, this one is I. This one is I. Yeah. There we go. There we go. Okay, I'll let you copy the code in a second. Everyone, please pay attention real quick. So we calculated our multipliers. We got the lower triangular matrix, said you need to finish to get the off diagonal ones. And then we applied Gauss elimination to get our upper triangular matrix, and we have zeros on the diagonal. Okay. So once you figure out how to get these ones on the diagonal, the last step is to check if A equals L times U. So you can do a little code thingy. So you can say if, so you let check equals L times U, A equals L times U. Right? If check equals A, then we print correct. Else print incorrect. And right now it's not going to be correct because you still need that diagonals. So remember, you can, what did I do this time? 44 else. There's something there. So remember, you can change them manually, right? So you go into your lower and then manually change those, or you can write a conditional for loop. All right. So practice that. Like I said, I'm going to be nice to you. So your lab has nothing to do with that. Let's check what the lab is. The lab is review. Who started already? Why are you cheating? So this one's gonna be review. So I just want to calculate the determinant. So last time I had you guys choose manually or optional, and then or manually or automatically. So again, you can do either or, but I really want you guys to practice how to do this using MATLAB only. So if you do it using math, that's fine. It's still gonna work, but I want you to automate it. That's number one. And then number two. Number two is gonna be basically like last time, it's just Gauss elimination. But I really need you guys to finish in class before we leave today, because last time it was just too much going over your code. So today it's due at the end of class. You have about 2 hours. I think you should be good because it's very similar to last week. And if you finish early, do me a favor, stick around, do your homework for this class, okay? And in fact, let's go over something real quick, because I was discussing with Dr. Barsanti, and you have some extra credit. So, go ahead. Okay, so yeah, so one of your homework is saying like, where can you use these in your classes? And then, I mean, the book has some pretty good examples. You can solve like systems of equations. You can do your like mechanical engineering classes. Like I said, your senior year, you're gonna have what's it called? Process control, process design. So that's all about for loops, all about automation and just like iterating through everything. So you have lots and lots of examples in the book. Review your own books, check all those examples. And then, yeah. And so, okay, everyone, please pay attention, because, right now, this is what I'm concerned about. These tips don't apply to you guys. These apply to the people that aren't here with us. And I have the people on Zoom, so I appreciate you guys are here. So if you have friends that they're not here today, I don't know, like help them. So here's some tips. First of all, what's your guys like study tip for this class so far? We're halfway done. What would you guys say is like the best thing? Textbook? Examples. So like read the examples, practice problems. Say again? Come to the lab. This side, what's your study tips? Review the lecture notes. Okay. All right. Yeah. So appreciate that, because, it's really important. Like you guys like help each other. Engineering has lots of projects. You have to work together. So I wouldn't be surprised, if you guys get paired up next year for your labs, right? That's how it goes with engineering. Please do me a favor. Everyone open your Canvas right now. Check your grades. See if there's something that you think, hey, look, I did the lab, that's not right. Or, I'm not comfortable with this, just let me know. If you email me, at least that communicates to me that you actually care. Otherwise, I'm just gonna assume that you're comfortable with your grades, right? And it's week 5, so I can do this now. I'm not gonna do this week 9 or 10. So I'm not gonna change your grades. So do this now, please, right now. Yeah, study the quizzes, the homeworks. So whatever your quizzes are gonna be like, that's gonna be what your exams are like. So try to kind of guess what she might ask you. Remember, there's a lot of theory mostly with the exams are mostly about theory. The labs are about application. Review the syllabus. So we have I think next week is the combined lecture, right? If I'm not mistaken. The following week? Okay, soon as the combined lecture, and then you have your project midterm, and then you have your final projects, okay? And those are really big percentages of your grades. Play the game. Grades are kind of just like a game, Squid Game or something, right? If you're stuck, do it by hand first, do the math, and then transfer to MATLAB. I know you guys want to jump right into the MATLAB because that's the point of the class, but seriously, if you just do the math first, it's going to make way more sense once you transfer to MATLAB. Like I said, extra credit. You have one homework extra credit this week. So maybe like if you keep doing problems, maybe, I don't know. I'm not the professor. Maybe if you keep doing problems, you might get extra credit. So keep that in mind. Work together, convince her, not me. So send a bunch of emails saying like, hey, we need extra credit. And if you do it earlier, you're more likely to get extra credit. If you wait till week 9, it's not gonna work. So, you know, I really shouldn't tell you guys this, but like I was really, really close to getting a certain grade. And then I was like trying to be early. And then she said like, you know, it is what it is, basically. So I did end up making that grade actually. So I'm glad about that. And so that's why it's really great that, you know, if you remember from the beginning of the quarter, you guys did your like how comfortable you are with this class. And then a lot of you guys said you weren't comfortable with code. So, I mean, I think y'all are doing more than fine with the code. I know it's a little tricky with the for loops, but like, let's just keep that up. So like I said, this lab is easy today, but please study for your midterms, stick around with lab. And then more importantly, the main reason I wanted to do this was to remind myself to have you guys check your grades right now. And then let me know what you're not comfortable with. And then yeah, make friends. Like I said, like it's all about like projects working together, right? And then you can always ask me questions. Okay, that's it for today. I'm going to stop the recording and then get started.